Let me first introduce myself. My name's Richard Lord. I'm actually with United Technologies. It's a division called Climate Controls and Securities now, which for most of you is Carrier. We've bought a bunch of companies, so we change our names many times. I happen to be I'm going to talk today about ASHRAE 90.1. I'm the co-vice chair of that committee. I've been on it for probably about 15 years now, also on 189 and a bunch of other ASHRAE committees. So what I want to try and do today is go through 90.1, 2016, and some of the changes that we've made in that standard. So I'll just kind of skip through these. We'll kind of focus on the 2016 standard, but I want to give you guys a little bit of background on what's going on with energy efficiency standards. It's kind of a complex environment out there, especially in commercial systems as to where we go. So I'll give you a little bit of background, a little bit of history that might help you guys a little bit. And I know you guys are all in commissioning, so I'll try and give you some highlights of some of the things we're trying to do in 90.1 on commissioning, which I think is a really important subject. So we'll kind of go through these. So let me just start off a little bit with overall building energy. I spent a lot of my time in Washington. There's a big focus on energy, and it's not just in the U.S., it's globally. We're seeing energy efficiency standards pop up all around the world, very, very quickly. Really the main reason everybody is going after energy efficiency is the energy cost, environmental issues. There's a lot of big issues that are now hitting us. I don't know if you guys are familiar with things like the Kigali Agreement. There's a lot of things that are really going to impact our industry over the next 30 years as they start to do stuff in this. And then also energy supply. A lot of great progress is made. I'll show you a slide in a minute of where we've gone, at least in 90.1, in terms of how efficiency's improved since 1975 when it kind of first started. Just a little bit of background. I'll talk primarily mostly on commercial buildings. Residential buildings tend to have separate efficiency standards. Most of them are kind of controlled by the federal government. And commercial buildings, for those of you guys that look at the details, it's really structures including new portions of buildings, existing buildings we're starting to cover, and then we cover residential buildings greater than 3 stories. So this is kind of a nice chart that one of the things we've started to do in recent years, we do what we call a determination, and Pacific Northwest Laboratories does this for us. But we take every change that we make in 90.1, and we have some 16 benchmark buildings that we go through and we analyze using Energy Plus, and we compare it against the prior one. This just shows we've done this all the way back to 1975 when they first started energy efficiency codes. And it kind of shows the improvements that we've made as an industry in terms of efficiency. So you can kind of see, as we've come along, you can see this gradual decrease in energy efficiency. Long about 2000, federal government, a lot of people started to focus on energy efficiency. And you can see how it rapidly has dropped. And some significant improvements as we come along here. We just finished 2016. We just did the determination. I'll show you in a minute how much energy we saved. And this is kind of the ASHRAE Board of Directors target. There's a lot of issues with that, that especially I'm a mechanical engineer. I do mechanical equipment. And there are a few things like first and second law of thermodynamics. You just can't keep increasing efficiency. So a lot of things we're looking at are new ways to improve efficiency. And, I'll talk a little bit about some of that stuff. But I thought you guys might like this. This kind of shows where we're going. We actually have a strategic plan for 2019. This is our target. Basically all these efficiency standards, you can see they're now 3-year cycles. So every efficiency standard, whether it's 90.1, whether it's IECC, they're all on a 3-year cycle. Department of Energy is on a 6-year cycle. So they'll tend to go after our equipment every 6 years. So when you look at energy efficiency standards, I talked a little bit about it. So you can look at building energy efficiency standards. You'll have residential energy efficiency standards. They're pretty much all IECC based. A lot of the requirements for residential equipment are controlled by the Department of Energy. So you hear us talk about, SEER values. These are what we call preemptive efficiency requirements. So if a state says, I want to implement 16 SEER, that violates federal law. So, and a couple states have tried that. You'll SEER some things, and you may hear a thing, SEER 2. They're coming up with a new metric, really innovative approach. We just call it SEER 2. But basically, they're heading towards 15 SEER, but when you do SEER 2, it'll drop back to 14.25 because they're increasing the statics on it to more of what real buildings have. But I'm going to focus primarily on commercial efficiency standards. The 2 that we have is the IECC and ASHRAE 90.1. I'll focus a lot on ASHRAE 90.1. A lot of what we do in the 90.1 committee is we write proposals and then we submit them to the IECC. So a lot of times, a lot of the requirements in here are harmonized, but not always. So, you know, you have to pay close attention to your state as to which one is in effect. And I'll talk in a minute about not everybody adopts the latest standard. So actually in this map, you'll see what states have adopted this, and I think you guys have a copy of this. I'll show you at the end where you can find these maps. Various states adopt efficiency standards when they get around to it. So, you know, I happen to live in Tennessee. They're kind of slow on energy efficiency standards, but I kind of like it because they don't have any taxes, so that's kind of why we live there. California is very aggressive. New York State's very aggressive. You know, some of the eastern states are very aggressive. Florida tends to be very aggressive. But you can see maps like these on what states have adopted what standard. A lot of times you'll see some of the standards are customized for a state. Even ASHRAE 90.1 is doing that now. ASHRAE 90.1 used to have one national standard. They're now customizing it, like there's a 90.1 standard that just went into effect in New York City. It's got a few changes that the New York City office wanted. So, you know, a lot of times look at your local standard and see what you can find on it. When you look at efficiency for commercial equipment, it's a very, very complex, especially on mechanical equipment. You know, we have light commercial, and you'll have minimum efficiencies that are federally regulated, like, you know, the SEER values are federally regulated. Then we'll also have higher tier requirements. You'll have Energy Star, you'll have CE, which does a lot of the rebate levels. You have Cal Green, you'll have LEED. Probably you guys are all familiar with a lot of these. Same thing when you get up into commercial. You'll have 90.1 requirements. Under federal law, 90.1 sets the minimum efficiency requirements, but then DOE has to rule on it. So DOE has to rule on it within 1 year. Sometimes they will agree, sometimes they won't. And in a minute, I'll show you some of the things that they didn't agree with. You know, and then you can see all these requirements in here. On commercial, we have even more tiered values. We have CE, Energy Star again, which is primarily small unitary commercial products. I don't know if you guys are familiar with the 189 standards. I actually happen to be on 189 since the beginning. That's a green building standard. It was kind of meant to not only address efficiency, but water use, environmental use, indoor air quality. A lot of new things in there. That's very tightly tied to LEED. And this is the first standard that in history, 189 is now a joint standard between IECC and ASHRAE. So there's really only one standard. And that'll be coming out this next round. Then you see FEMP, which is the federal government. I actually had that twice, Cal Green, LEED. And then on the useful guide, if you guys ever want to look at, there's what they call 30%, 50%, and net zero energy design guides that ASHRAE puts out. And they have some very good guidelines on how to make an efficient building. So for the rest of this session, we're going to kind of dive into 90.1. I won't go through the full training on 90.1. That would take us pretty much a day, but I'm just going to kind of highlight some of the changes that we did in the standard. First of all, 90.1 is kind of organized in these chapters. You know, you can see it's got a purpose, a scope, administration. That gets into some new requirements, especially with performance approaches with Appendix G, and I'll talk about that in a minute. And then the main ones are envelope, heating, ventilation, and air conditioning. That's kind of where I spend most of my time. Service, water heating, power, lighting. Other equipment is just some small things. Energy cost budget, we'll talk about that, and then some of the normative reference. An important one that we're going to spend some time today on is Appendix G. Any of you who've done LEED submittals, you're quite familiar with that appendix. That is now a third compliance path in 90.1. Honest opinion, I think it'll replace Chapter 11 down the road because it's just a much more user-friendly approach. Other thing, just to let you know, it's kind of a understanding is you have a lot of standards. Once they have a user guide, it kind of tells you it's a complex standard. So I happen to chair the User's Guide Committee, and we're in the process of doing that right now. You know, it's a good book to get that in there you'll find examples, you know, figures, things like that to help you understand it. Just give you guys a little heads up. One of the things we're trying to do, I'm on a committee in ASHRAE that's trying to make these books a lot more usable. So one of the things you're going to see come probably January at the winter meeting in Chicago, they're going to roll out an online version of 90.1. So you'll be able to look at the stuff, be able to put notes in it, you'll be able to pull up the standard and the user's manual side by side. some nifty little things in there, like if your mouse goes over definition, up will come the definition. So it's kind of a neat approach that we're trying to get to, and you'll see in a minute why we did that, what we're doing in the standard to really support electronic communications. So, looking at 90.1 updates, it's the overall goal is the consensus standard. So we spend a lot of time on economic justification. There's a lot of detailed. I'm a strong advocate on standard work. One of the things that's available to you guys if you ever want it. We've created 16 benchmark buildings. We have benchmark cities for every climate zone. We'll talk about climate zones in a minute. All that stuff is really useful if you're trying to just do some studies for your local environment. And we analyze each of these changes in every of the 19 climate zones. One of the goals we had for 2016 was to improve the ease of use. We had a lot of feedback that, these standards are getting so complex and states are starting to push back and say, we can't handle this many changes. Trying to move to electronic communications, I talked about that a little bit. Trying to consider the energy of the whole building. When we set a goal for 90.1, it's now based on the whole building. We try to look at climate data. I'll talk in a minute about climate data. I don't know if you guys are familiar with ASHRAE 169, but it kind of does demonstrate that the environment's changing a little bit, and I'll show you that in a minute. And then trying to move towards performance approaches. If any of you guys have ever been on an efficiency standard, they kind of like to tell us how to design buildings and pick specific equipment. I'm an advocate, and I happen to be in a group that's an innovative group at United Technologies, and we try and set the requirements, but let you guys be creative how you get there. So if you can trade off something for something else, let you do it. So we're trying to move in that direction, get away from just full load metrics, trying to get to part load metrics, get to higher level metrics. So that's one of the things we're working towards. Just to give you a feel, we had 125 addendum. That's a lot of addendums. This committee meets 4 times a year face-to-face. We just met last week for 3 days. One of the big things we had was a major format change. I'll show you that in a minute. We adopted the new climate data, which you see right here. Appendix G is a new compliance path, which is really, really getting a lot of support. Some states are adopting that earlier. And then I'll show you right here, this is the energy savings that we got. We do this determination. We ended up saving 6.8% energy, 8% on energy costs. That's as designed. Now, you guys will know, and you'll tell me that design buildings don't run the way they should. So, this is as designed as the way it's at. So you can kind of see here, it may be a little hard to view, but this kind of shows you the format. Old standards always used to be 2-column. When you read them, made it easy to read. It doesn't work well when you're on a computer screen. So what we did is we went to a single format. We tried to highlight some of the tables. We haven't gone all the way to color yet, but you can see we got shading in tables that makes it easy to see some of the figures. So this is exactly the same requirements. Happens to be damper leakage in a building. This was the old table. This is the new table. And this is the format that you see here. And we kind of divide sections, and we're kind of seeing how it goes. Now the bad news, is we went from 278 pages to 388, but electronically it doesn't make a difference. The other thing we worked a lot on, I talked about climate zones. So we divide the world into what we call 8 climate zones. They range from a warm climate zone all the way to a cold climate zone. So you're right now in climate zone 1. Climate zone 0 is a new climate zone we added, which is the Middle East and India, so basically along the equator. And then we take each of those climate zones and we divide them into A, B, and C. A would be a humid zone, so we're in climate zone 1A right now. It's a humid climate zone. 1B would be like Arizona. 1C is a marine climate zone. These are usually along, it's kind of unique to the California guys. They always tend to have a lot of influence on standards. So these are all C climate zones. So when you total it up, we have 19 climate zones. Alaska would be climate zone 8, usually 8A. And then you see the Middle East is I'll show you that in a minute. Let me just show you this. This is the old climate zone map. This is the new climate zone map. You can visually see in here, I happen to live just south of Nashville, so I'm right there in that little peak. So I used to be in climate zone 4A, I'm now in climate zone 3A, so it's moved north. And what we did to determine that, if you guys are modeling type guys, you typically use TMY2, well we've adopted a TMY3, and what that is, TMY data is a 20-year period of weather data, and they try and pick a typical year. So they throw out the extreme days and get an average year. So that's what most modelers will use. Well, if you look at TMY3 versus TMY2, the temperatures did go up. So it kind of supports a little bit of what the environmental guy's saying. So we kind of readjusted a lot of the climate zones. This is kind of important to you because, for example, I went from 4A to 3A. That can actually change insulation requirements. It can change things like economizer requirements and some of the things that you have to do in buildings. So it caused a lot of people to focus on it. It's going to be a little confusing over the next few years because 90.1 has adopted this. IECC has not adopted this. So we're going to have old versus new maps for a while. One thing that's been extremely helpful, I do a lot of work overseas, especially in this Middle East area. Having a global map helped us a lot, because like Middle East was trying to say we need to qualify all products at 125 degrees. Well, I looked at the weather data and their design point at 0.4% is really 115. So, we've used this data a lot to quantify the world. We actually now have benchmark cities for each of these climate zones, both in the U.S. and globally. So if you guys ever need that, let us know. We can share that sort of information. So let's just get into the summaries now. I'll just kind of go through these chapters quickly. I'm not going to dive into the details. Hopefully you guys can get a copy of this presentation, come back and look at it. There's a lot of finite details that we did with 125 addendums. So, let's just get into the overall scope. One of the things, ASHRAE is very picky on changing scope, but, we concentrate on new buildings and their systems, new portions of buildings and their systems, new systems and equipment in existing buildings. So if you change out a rooftop or you change out a chiller, it has to be brought up to standards. And we actually added some new requirements in there, and I'll get into that in a minute. Doesn't apply to single-family houses, doesn't apply to multifamily, less 3 stories and less, buildings that don't use electricity or fossil fuel. And certain parts of buildings may be exempt. One of the things we're trying to do is, as we move along, do we cover other things? Like one of the major efforts we had over the last cycle was to cover data centers. They use 8% of the power in the United States. And that was quite an emotional thing because, data center guys said, hey, reliability is all we care about. We don't want your credit card machine to go down and you can't get on an airplane or anything like that. So, but it was very emotional, and there's actually a new standard coming out on data centers. It's out now called 90.4, and they've done some very interesting things. Always in cases, if there's safety or health, those always preempt anything that's in one of these standards. But you can kind of look at these standards. They're broken into, we've added these flow charts in there. You can see the various paths. You have envelope, mechanical, service, hot water heating, power, lighting, and then all mandatory provisions. And then you have various approaches. You can go a prescriptive approach. Some sections will have a simplified approach. You can do energy cost budget, which doesn't really get used much anymore. And then the performance rating approach, which is now a normative approach. This is what you would have used for LEED. So we'll dive into it. I'll go through envelope. I'm not an expert on envelope, but I'll try and give you the details of what we did. We always define various spaces, whether it's a ventilated attic, a semi-heated storage, conditioned space, ventilated crawl space, and unconditioned space. So you'll see a lot of these figures in like the user's manual that'll help you understand what's going on. So with each of these chapters, it'll show you a flow chart. It'll show you, what you have to do to comply. Pretty much the same strategy. You'll have a definition of the compliance path, mandatory provisions, a prescriptive path. Envelope has a trade-off approach that they allow. A lot of people like to look at, more window-to-wall ratio, especially on a lot of the high-rise buildings. Then you have the energy cost budget, and then the new performance approach, and we'll get into that later on. So I'll just give you some highlights. So some of the things in, fenestration, they basically changed a lot of the U factors, anywhere from 8 to 22% in northern climate zones and 0 to 10% in the southern climate zones. They also reduced the SHGC by 12% in hot zones and 5 to 10% in zones 4 to 5. Did a lot of work on orientation of the building. Especially when you're doing performance approach, you have to look at all 4 orientations. And then they did some credits for shading and permanent projections on a lot of buildings. They also did some work on walls, roofs, and doors, especially on garage doors. There's some requirements you'll see in there on those, especially with fast opening and closing doors. Some new requirements on infiltration, and this is probably something you guys want to look at closely, especially in commissioning of buildings. There's some new requirements on building air leakage testing added in section 5. You'll see that. And then there's some alternate approaches on the whole building approach that you'll kind of see in there. So you guys might want to take a look at that, get familiar with that as when your states adopt it. Some of the additional items, thresholds for unconditioned spaces, they change those a little bit based on, where buildings are going, what the levels are. So they essentially, modified those sums, and you can kind of see them in there. They added a new section 5.9, which was added to the standard to increase delivered performance by inspecting and verifying the requirements of section 5. So again, that's something you guys might want to dive into a little bit of the details on. So now let's drop into chapter 6, 7, and 10. This is basically all the mechanical equipment. You can kind of see all the equipment that's covered in there, ranging from a window unit up to a large chiller or cooling tower, but also buried in there is motor efficiencies. There's some new requirements in there. You'll see in a minute, I'll talk about it with dedicated outdoor systems. There's some new requirements on fan performance, which actually there's more coming on that out of the federal government. So a lot of the changes happen in the mechanical section. There's a lot of focus in that area. Out of the 125 addendum, 52 came out of the mechanical section. One thing I'll warn you, there's a lot of things in the mechanical section, especially on equipment efficiencies, that are date sensitive. So it may say this efficiency on rooftops, it's in the standard, it was in the 2013 standard, but it didn't have an effective date until 2016. A lot of redesign and requalification goes along with that. So we've started putting effective dates in the standard. So let's just dive right into the details. So again, the kind of flow chart, I'll point out a couple sections in there. In mechanical, they have a simplified approach, which is usually unitary, small equipment on office buildings, 5,000 square foot buildings. A little bit of statistic for you guys who may not know this, but 53% of the buildings are less than 5,000 square feet, 83% are less than 25,000 square feet. So a lot of focus in that area as we look at it. Then you got the prescriptive requirements, a lot of details in there. I'll get into some of those. First time we've ever used this section, which is an alternate performance approach. And you'll see in the standard, there's a thing in there called PUE, and it's for data centers. And it's the ratio of total energy to the IT energy. So if you got to a PUE of 1, that means you have no mechanical cooling. So we've set actually prescriptive limits, like 1.2, 1.5 by climate zone. And there's more of that coming in 90.4. And then the performance approach, we'll get into that later on in the presentation. So one of the things we had to do was adapt to all these new climate zones. So we went in and, because we now had a new climate zone 0, you guys don't have to worry about, but climate zone 0 is, the Middle East, India, a lot of people live in those climate zones. We had to go through and modify all those tables so you can see all these tables that change, because a lot of requirements are climate zone specific. This was a new one, and it's kind of an important one. A lot of times, especially at rooftops, and I do a lot of work in rooftop business, about 60% of the sales are replacement units. So you can kind of see a typical replacement rooftop unit here with a conversion curve, which happens a lot, and you'll see those on buildings. A lot of times it just said you had to meet the minimum efficiency. Now on a rooftop, when you replace it, you got to meet thermostat requirements, you got to meet economizer requirements. So if this was in a climate zone that like 3A back a while ago didn't require economizers, it does now require economizers. So you have to put an economizer on that unit. And you can kind of see all those requirements in there. So just pay attention to that if you're involved in any of the replacement equipment. A lot of changes to the equipment tables. I won't get into a lot of the details. I'll just highlight a few of them. So, I tend to know these by memory. So table 1 is unitary equipment. Table 2 is heat pump equipment. Those have some effective date changes in there. This one got a little complicated because when we do a change, the Department of Energy has to rule on it within 1 year. They didn't agree with our change, and they said we want to go further. So you're actually going to see in a minute, I'll show you that we've actually defined efficiency requirements out through the year 2023 now. Water chilling packages, I'll cover that a little bit. PTAC type units, warm air furnaces, boilers, performance requirements. You can kind of see the highlights of some of these changes in here as to what they did, and some didn't change at all. More of the tables, you can see a lot of focus on variable refrigerant flow systems. When you go outside the United States, that's 90% of the units that are put on buildings. In the United States, it's a lot less. So we put in efficiency requirements in there. I'll talk about those in a minute. More of them are coming. New category for computer room units. If you guys are familiar with crack units, These are the stand-up type units that you put in a computer room. Those now have efficiency levels, some requirements on refrigerator freezers, commercial refrigeration, pool dehumidifiers. You wouldn't think that's a big market, but we actually added a table in there on pool dehumidifiers and has a metric that you're not familiar with. DOAS equipment. A lot of focus in our industry on dedicated outdoor systems. So there's, and I think it's the Washington or Seattle have adopted this as mandatory on all buildings, but there was no efficiency metric. So we now have an efficiency metric for 100% outdoor air units with and without energy recovery, and I'll talk about those. You can see the two tables here, 15 and 16. So I'll go through these quickly. Table 1 and 2 is unitary equipment. It's probably the largest volume business in terms of sales. I think 1.5 million units sold in this. It's divided into two categories. Less than 65,000, which kind of comes under the SEER rating, is controlled by the federal government. Greater than 65,000 up to 760,000 is set by ASHRAE, reviewed by the federal government. And then all these things are what we call preemptive standards. So if California wants to adopt something higher than 90.1, it's against federal law. They can do it on a green building, but they can't do it on a minimum efficiency building. So you can see here, just to show you how complex our life is, what we ended up doing is in 90.1, you'll see this table, similar to this one, effective January 1, 2016. There's a lot of rules in the Federal Energy Policy Act that says when efficiency standards go into effect. And when they ruled on this, the preemptive requirements out of the Department of Energy will go into effect on January 1, 2018. So no matter what states do, this will then become the law in the state. Between 2016 and 2018, let's say New York City adopted 90.1, they can implement those efficiency requirements on new buildings, but not on replacement equipment. So it's pretty complicated. Most people don't know that. We've actually gone out and defined efficiency requirements for 2023. You'll see in here a little bit of detail. There's two metrics in here. There's what we call an EER and an IER. An IER is a part load metric, annualized metric. I'm the guy that actually came up with that metric. And that's where we're focusing most of our energy. You can see this one, you guys can't read it too well. It's 12.2, but you can see it goes to 14.1. This is where all the technology in the industry is going. This is why you see units coming out with 2-speed fans in it, multiple compressors, multiple stages. That's how you get IERs up. And, you know, we've kind of demonstrated in the industry you can get as high as 19s and 20s. And that's a pretty good indication of what you'll save in a year. So you'll see that table coming along. Chillers, actually I spent a lot of my time on chillers and actually be in Washington all next week on that. Chillers are essentially kind of at max tech. When we say max tech, you know, you got a chiller, and I've spent a lot of my life designing chillers. When you get a heat exchanger at a 1-degree approach, if you go back to your college days, you'll add a lot of surface to go from 1 degree to a ½ degree, and it may not be the best economical approach. So one of the things we did in chillers, and this took me about 6 years to get this through the standards, we came up, we call a path A and a path B. Path A is full load intensive, path B is part load intensive, really after units that have variable speed on them. And I'll be honest with you, probably in 5 years, I think path A will go away and everybody will be at path B, because most chillers are going in variable speed. They have much higher IPLVs on them, and kind of where the industry's going in that direction. The other thing is we made some minor changes to heat rejection equipment. You'll see a couple of the numbers changed. This number went up just a little bit. It used to be 38.2. This is really not a good metric for cooling towers. It's really just the energy of the fans. So it's fan power per GPM of power. One of the things we're working on is an approach. And I've seen this, and hopefully you guys are better than this, but a lot of people in a very dry climate zone say, I'm designing at 85-degree water, especially in California. And you really end up with a little tiny cooling tower, and you could put in a much more efficient system if you looked at your cooling tower. And there's some nice papers published by ASHRAE on, you know, optimizing the system, kind of a hot button for me where I think we should be going. A lot of requirements on VRF, so that's a very much growing industry. You know, a lot of buildings are going in VRFs. I know of a football stadium in California that's all VRFs, which I was surprised it went that large. So, but you can kind of see the numbers in there. They follow the same thing as unitary equipment. They have SEERs down at the small size, then they go IERs. Same approach as rooftops. This is the computer room units. I won't get into the details, but there's 3 classes. Any of you guys do computer room units? They're getting pretty novel in that industry. You know, instead of keeping a computer room at 75, 70 degrees, they take them up to 100 degrees. Once you do that, you can start doing free cooling a lot more. There are people in Canada actually putting in data centers with no mechanical cooling because, you know, when it's cold outdoors, you can just free cool them. So you get a data center that's now got 100-degree aisle temperatures. They'll have a hot aisle and a cool aisle. Interesting thing, we ran a model. One of the benchmark models we have is an office building, and it's got a data center in the basement. And we noticed that the first floor was running all the time now. Well, it's the heat transfer through the walls, which are really set up for interior walls. They really should be exterior walls because they didn't have enough insulation in them. So things you just have to look at. Pool dehumidifiers. You'll see in here an MER. That's a new metric that you may never heard of. It's a moisture removal rate efficiency. So these things are really targeted for dehumidification. So they came up with this thing of MER. So it's basically latent per energy use. So it's kind of a COP of energy use on the latent side. Then DOAS equipment, again, you'll see they kind of follow the same thing. Most of the DOAS equipment is dedicated to remove moisture, although not all of it. And you can see they have moisture removal rates in there. There's a new AHRAE standard called 920. They're trying to get a certification program, but we need to find a laboratory that really can test this type of equipment. A lot of prescriptive requirements in there, which I know you guys need to focus on commissioning. So we spent a lot of time on hotels and motels, and I'm very familiar with this because I spent half my life in hotels, but there's now requirements in there on setback, setup, shutting off ventilation to hotel rooms. This kind of pushes DOAS equipment into being variable volume now. It can't be just fixed volume. So a lot of new requirements in there. And one of the things you'll find, most hotels are pretty well automated now. You know, we happen to do a lot of the locks in hotels, and they're all communicating, so there's a lot of neat things that you can now do in hotels in terms of controlling energy use and occupancy in hotel rooms. This one's kind of an important one to you, and you may ask, why did we do this? We put mandatory requirements in there on chill water plant modeling larger than 1,500 tons. This is a precursor to the whole connected building syndrome, getting dashboards, monitoring building, things that you guys probably do a lot of. You know, once you put this stuff in there as mandatory and you put in requirements that, you know, make it easy to monitor this stuff, now you can come back later on and do commissioning, continuous commissioning, and one that I'm kind of an advocate on is diagnostics and prognostics. Can we remotely monitor this stuff? You know, predict when this heat exchanger is fouled, predict when that cooling tower fan fails, so that, you know, you don't have to do inspection and then come back later on with the parts. You can schedule your work. So it's kind of an interesting thing of where the industry's going. A lot of other things on miscellaneous controls. I know in the prior talk he was talking about some of this stuff. We a lot more requirements on setback requirements. You know, we used to have the requirement that it must be capable of, but then we looked at a lot of buildings and nobody ever configured it. So now we're saying you really need to configure it, and that's where you guys come into play. Chill water reset control, a lot of benefits that you can get out of that. Same thing true with economizers. You can get a lot of benefits out of that when you do reset. One of the things that I've done a lot of studies on, and I always like to pick on San Francisco because it's the perfect climate zone for an economizer, but we've done a lot of improvements on economizers. You know, over the years, there was some surveys done. Some of you guys may have been involved where they went out and they looked at economizers on the roof and said 75% of them weren't working. You know, some of them, the wires were disconnected. Some guys, you know, shut off the outdoor intakes because it actually saves energy, but it doesn't do much for indoor air quality. And so we've gone back, and now all of these economizers, and it really started in California, they have mandatory reliability requirements. They have mandatory diagnostics and prognostics, like the economizers will now tell you it's working properly, the dampers are stuck, things like that. So all of this all started in Title 24. It's now in the IECC, and it's now in ASHRAE 90.1. So these economizers have improved dramatically. They now have blade seals, they have damper seals. Most of the motors in these now are what I call smart motors. They're digitally stepper motors, so they can tell what their position is. So there's a lot of neat things you can do with these things. And then we re-emphasize what we call integrated economizers. This would be economizer operation here, and this is a typical load profile for an office building in San Francisco. So this is cooling, this is heating, and economizer will satisfy all this load. Then we have what we call integrated economizer. Run your economizer, turn on your mechanical cooling. You'll see some requirements in the standard about that. And then at the very end, you have mechanical cooling. We focused all of our time on this point up here, which never runs. So now we're focusing a lot more on these hours down in here. And this gets reflected in things like IER. Economizer's not in IER now. It probably will be after 2023. And so we're starting to look at things like that. So other thing we did is you can always tell somebody that didn't do a right economizer. You see this on a lot of fast food restaurants. They'll put in an economizer with a barometric relief, have a half-inch of return static. You open the door and you hear a whistle. So we put some requirements in there around power exhaust, that it should be variable flow to match the building. There were some requirements in California already. So you'll see some of those things in there in terms of where you go to these various types of systems. The other thing that's probably one of the biggest energy savings we did on mechanical equipment is when you look at a building and you look at the total energy used. Fan power is a huge part of building energy. And a lot of people run their fans all the time because of ventilation. One of the things we found out is a lot of times we can go to 2/3 speed or reduced speed on a constant volume system. So you'll see all of these old constant volume units are no longer constant volume. They're space controlled temperature, but they have 2-speed fans. Some of them have 3-speed fans. And if you guys know the fan laws, power goes down to the cube of the speed. So you get huge savings on fan power by doing this. And so that's now in the standard. It's in IECC. It's in 90.1. It's not being well enforced, and that's something that I know some of the states are starting to look at. Parallel fan, we put some requirements in there on fan-powered VAV terminals, so you'll see some of that in there. I won't dive into some of the details on that. There's also additional control requirements in there that were in the prior version that you guys might want to take a look at. Hydronic variable flow, we got into some requirements. You know, more and more systems are going variable flow. Inverters are becoming very, very common out there. The prices are dropping all the time, so there's requirements in there on variable flow, not just for chill water, but for hot water too. And it's climate zone specific. You'll see this down here in this table. It's the first time we've done that. This one's kind of an interesting one. We were talking just before the session. You know, I grew up in the industry. We've always designed to a 10-degree delta T since the beginning of time. We've now switched it to a 15-degree delta T. I'm not an advocate of this approach, but why they did this is that, you know, pumping power is a significant part of it. When you start to look at it as a system, if you go to a 15-degree delta T, you're pumping less water, spending less energy on pumping power, and it really doesn't have much of an impact on the chiller efficiency, so we can kind of handle it. It kind of tells us who design chillers that we may want to change the way we design chillers. A lot of requirements in there on energy recovery. This is kind of a very nice technology, especially when you're bringing in outside air. We kind of changed the definition a little bit in there. You'll see that in there. These all require what we call a 50% effectiveness. That's not too difficult to get. You'll see most enthalpy type wheels are up in the 60 to 70s, but we left it at 50 for some of the plate type heat exchangers that are used. And we just did an addendum last week on this. We tend to spend a lot of time on energy recovery. There's a table in there now that has this that basically says in what climate zone, for what supply air volume, in what percent outdoor air do you have to have enthalpy or energy recovery. We used to have some of these climate zones had 0, and that's kind of pushing it too much. So we put some lower limits where technology is available. So these are kind of aimed at high-rise residential. Transfer air, there's some requirements in there about transfer of air. This is where you supply air to a space, pulling it from another zone. We put some requirements in there. You might want to pay attention to that, especially during the commissioning phase, so you can go back and take a look at that. Now let's dive into service water heating. I'll speed up a little bit because we're going to run out of time here. Service water heating is a pretty straightforward section. We just added an Appendix G. The only probably thing in there, there's a lot of recirculated loops, especially in commercial buildings. They put some requirements in there on insulation and takeoff lines, so you'll see that in there. You may have to look at that as you go through some of the commissioning documents that you do. Other equipment, very straightforward section. This gets into motors. This is a federally controlled thing, and they've been after motors in a big way. And you'll see in there's a lot of tables. These were just updated. These are pretty much, I think, at max tech now. You can kind of see, you get efficiencies up at 96%. Yeah, you can go to 97, but is it worth the effort? So where they focused a lot of their effort more was on small motors, and that's where a lot of the technology has come through. I don't know if you guys are familiar with ECM motors, but they're permanent magnet motor. They have much, much higher efficiencies, and the industry's going this way in a big way. So you'll see most fan-powered, most residential units are going to have ECM motors in them. They're actually a kind of a nifty motor because they're a smart motor. You can kind of tell they're rotating and things like that. So that's coming along. This is the first time we've ever done this. I have to work for a company that makes elevators. We put some requirements in there really to set the stage for elevators. Elevators use anywhere from, I think it's 4 to 5% of the energy in the United States, especially hydraulic elevators. They're very energy intensive. Most of the traction drive elevators have regenerative drives on them now. They're all inverter drives, so they tend to recover energy. But we basically now have to put a rating in there per this new ISO standard. It's the first energy efficiency standard written on an elevator. No requirements yet, but it's really just to get the metric started. Let's jump into lighting now. I'll go through this quickly. Lighting, probably the biggest thing that's come along in that is LED lighting, and you guys will all see that. And then controls. So, lighting has a simplified building compliance path. They have a building area method, space-by-space approach, energy budget, and the performance approach. So, lighting power densities, interior lighting power densities were revised, and primarily because of LEDs. You'll see these LEDs coming everywhere. Now, it's not they're particularly picking on a given technology, but they're basically reflecting what LEDs have done. So, you see the power density have changed, space-by-space levels have changed, building areas have changed. So you'll see all of those. This is kind of the slide that they put in. We're not prescriptively defining LEDs. You can still go other types of lights, but, generally the industry is going this way pretty quickly because the cost of these is dropping significantly, and they offer some nice advantages in terms of how you can control them, and they're actually smart control devices. So, we expect more and more to come. That committee's working on it. One of their big focuses now is parking lot lighting, trying to cover a lot of the requirements on that. They've also gone after retail lighting, dropped some of the levels in there. You'll see some of those, basically a 25% reduction. Exterior lighting, again, the same thing. I think there's a special exemption for Las Vegas, but we won't go there on that one. So, and then, one of the other big things that's coming a long ways, and this is probably important to you guys, controls of lighting is getting very, very much happening. These are smart control devices. We actually have a collaborative group. We look at occupancy and mechanical, but these guys also know occupancy, and if we could communicate, you don't have to put two sensors in the same room. So we're trying to look at how we can leverage some of that stuff, but, a lot of new requirements on partially on, auto on-off control and things like that they've added to the standard that's probably important to you guys. Some other things on exterior lighting, light power densities, what they have to do on terms of turn down. There's also requirements in there on signage, what they have to do with some of those. They actually went after dwelling units, so they have requirements now on high-rise, what you have to do for lighting controls. And then also lighting alterations, retrofits, what you have to do with some of the requirements on those. Power, DOE seems to like to focus on transformers, so there's efficiency requirements in there on transformers. This section also kind of covers control of outlets, and this is one that 90.1 implemented, where you have to control outlets, and we always kid around that just sold more extension cords because people wire around them. So, but we're trying. So you can kind of see the requirements here and what they have for sections. They went after dry transformers, not liquid-filled transformers, and then a little bit on voltage drop. You'll see that. Last section I'm going to dive into is Appendix G. You guys may get involved in this, if you're involved in LEED, where you're after points. This is really, really an important thing to get familiar with. And LEED used to use Appendix G. It was actually generated for LEED, but we're changing the way we're going about it. So in the past, we used to just have two approaches. I'll go through these pretty quickly. We used to have the ECB approach and the prescriptive approach. ECB, you had to take your as-designed building and then design it like it was meet minimum prescriptive requirements. Then you had to compare your new building as you want to design it versus the baseline building. So you ended up making a lot of models. And we're trying to get away from doing that, trying to get to a more defined baseline is what we're trying to do. So I'm not going to spend a lot of time at these. Appendix G was a informative appendix. It was really generated for LEED. We work closely with LEED. It was done, it's a mandatory requirement in 189. Same thing with the IGCC, which is now common with 189. Some of the tax credits were there, and Federal Energy Management Program also used it. And you guys probably will know this. I won't get into the details. This is what you assume for the baseline. So you basically had to do two models, your as design and then your proposed building, and then you had to show that you were better. One of the things, if you understand about modeling, and a lot of people in government like to think, well, let's set an EUI target for a building. Modeling's not that accurate. We've done a lot of sensitivity studies, and you can't predict the energy of a building that accurately. It's a lot of the assumptions you make, but a very good way is to compare a baseline building versus a proposed building using the same tools, the same assumptions. So that's where we tend to focus, at least in energy standards. In the past we had Appendix G. This was basically used for LEED. We'll skip through that and went through that. You ended up having to generate guys that did models. You ended up with a lot of different models that you might have to generate for a building. If you wanted to get a tax credit, if you want to go for Title 24, if you're trying to get LEED points, it made modelers' lives very, very complex. And modeling is an expensive effort to do. You had a lot of different standards, whether you're trying to go for IECC, whether you're going for a green building standard, all those sort of things. So it made guys' lives very complicated. Baseline was always a moving target, so every time we updated 90.1, updated the baseline, so that made your life complicated. So where we're going now is, I'll skip through this, it's not that important. What we're doing is we've made with Addendum BM, and that was kind of unique, we released Addendum BM all by itself because everybody wanted it, and New York State adopted it really, really quickly, made it a performance compliance path. So now it's normative. What we did, which is really unique, and I kind of like it, we froze the baseline. So the baseline now is 2004. It will never change. So what we're now doing is spending all of our time defining default equipment models, like one of the things I'm working on are default chiller models that you just copy, paste into your model, and off you go and run. You don't have to try and create a model, go ask one of us manufacturers for a baseline model that meets minimum efficiency and things like that. So that's all in there. Then we came up with this performance index, which is your proposed building versus the baseline. So everything's relative to 2004. You'll see some of the details here. I won't get into that. Now what you'll see in 90.1, which is a very important table, we created a table, and there's a lot of discussion about this. We started off, we were going to have just one column that was common for the U.S., and we pushed back and said, it really needs to be climate zone specific. And you can kind of see, let's take healthcare. In climate zone 1A, it's 0.64 of the baseline. In climate zone 8, it's 0.56. So an improvement over what it is. What's going to happen over time now, these numbers will keep changing. So we'll come along later and say, okay, in 2019, let's make that 0.64 a 0.59. Now, we have to go back and demonstrate that you can get there. We just can't arbitrarily go in and say, decrease it by 10% and hope that you get there. There's one standard that did do that, which I don't agree with. But so, we're working at this stuff. And then what will happen is LEED will come along and say, hey, you got to be 5% better than this. So your baseline's fixed, makes your lives as a modeler much, much easier. So, you'll kind of see the future of where we're going. So here's 2010, here's baseline 2004, 2017. And then where we're going, everybody wants to get to net zero, whether we'll get there or not. It's a debate. California actually has a law that says they're going to get there, I think, by 2020. So now, you remember that chart we had before. Now you have one default baseline. You can use it for LEED. You can use for energy code compliance, IGCC, 189, tax credits, federal buildings. Makes your life a lot easier. And then this is kind of what LEED's talking about, where what they will do is change those metrics. So, this is kind of a major change to the standard. It's in creation of tools. So, we're coming up with a lot of default tools that'll make your guys' lives much, much easier in terms of building modeling. And then there's some other changes. I'll go through these quickly. They changed some of the factors and some of the default things. You're going to see more and more of this. What you can do with baseline heat pumps, what you do with some of those equipment, what you can do regarding heating-only systems. We added in requirements for refrigeration. You'll see these complex tables that are in the Chapter 6. Some requirements on elevators now. It's the first time they put elevators into the standards, so you'll see it in Appendix G. And then I put this in here. There's a lot of good information. Yep, I'm just about there. a lot of good information out there that you can use. So one of the things I wanted to let you know, you can order ASHRAE 90.1 directly from the ASHRAE site. You can also view it free of charge. Any of the ASHRAE standards all the way back, I think, to 1989, you can go onto the ASHRAE webpage, you can review them, you can't print them, you can't download them, but if you just have a quick question, you can go in there and loom them, you don't have to buy them. Like I said, coming along the line, there will be a portal. They haven't figured out the economic model, but I think they're trending towards, if you're an ASHRAE member, you get access to those, and you can actually download sections, like if you wanted to copy a section and send it to an architect and say, here's an important section, you can lift that out. It's got a lot of neat features in it that we're heading towards. Other standards you want to get familiar with: 62, 189, 90.4 is the new data center, 169 is climate data. So if you ever need climate data, there's some 4,000 climate zones or weather stations that they now use. The IEC standard, ComCheck, as you guys probably familiar with that. Here's some good stuff. There's a site called Building Codes Assistance Project. They have some if you want a full presentation on 90.1, you can get it up there, you can download it, use it at your local chapters or in your own office. DOE also has a website. Both these sites actually have some things that tell you what state has adopted what standard, when they're going to adopt it, and then very important in there, they have rebates. And rebates, I don't know if you guys follow that closely, that's a significant business. And what a lot of companies or a lot of states are now doing, what they call upstream rebates. So the rebate goes to the salesman, it doesn't go to the owner. So it encourages people to sell high efficiency equipment. And some of these rebates can be significant from what I've seen. Then you got the ASHRAE addendums, if you ever want to look at addendums. RATAs, we always make mistakes in standards, so you can see those out there. And then interpretations, if you guys ever have a question, you can do what they call an informal interpretation, we'll answer it, or you can do a formal one and then it gets posted, and then you can use it for code compliance. So there, I'll stop. I think we're pretty much on time. I got maybe 5-10 minutes for